of the rebar. And this is H over here. Okay? So look at what I've got to do. The center of gravity of two bars that are exactly the same function, which is main steel, is the center of the two bars, which is the top of this bar or the bottom of this bar. So for me to get D, I have to take 21 inches. I have to subtract the 3 inches to get to the bottom. Then I got 1 bar diameter instead of a half a bar diameter. Last time we had a half. Those are number 8 bars. Hopefully you realize the number 8 bar is 1 inch. So if I want a D, I take H minus a bar diameter minus cover, 21 minus 1 minus 3. I need that number. So D is 17 inches. So this takes care of all of my data, my loads and everything miscellaneous associated with this. So I'm going to put this down to here. Okay, so now we got ourselves in a position where we know everything about it, except we've got to check concrete and size the steel. So we've got our 2 left. We had started out with 4, dirt, loads, concrete, and steel. We've got the concrete and the steel left to play with. So I'm going to erase this. And I can erase, I'm going to erase that too to get it out of my hair. And I can erase this. I got the numbers I need. I need this guy, and I need this guy, and I need this guy. So let's do it. So we just finished letter N. Now we're going to letter O. Okay, letter O. What am I doing here? This should look familiar. I've got the moment associated with loading. This is going to give me the resisting moment associated with materials and size. So I'm going to put this MR resisting. This is the actual moment. This is what it resists. So this is the actual versus allowable. R B D squared should not be anything foreign to you. Notice the B became a W. So for this equation, I'm just going to rewrite it and make that a W. And everything else makes sense. So I got to go to the table on page 423, and I've got concrete and steel. Steel is 40, concrete is 3. So let's go back to page 423. And I'm there. And I look at 40 first and 3 second, and I end up with 1.149. 1.149. W is 105. D is 17 squared. And if I multiply those 3 numbers, I'm going to end up with inch kips. Inch kips. So let's turn 1.149 times 105 times 17 squared. 34. 866 inch kips. Resisting, allowable, actual. Okay, I'm in, this is inch pounds. So I'm going to compare it to kips. If I do that, this goes into this 3067 inch kips. All I do is divide by 1,000. 3067 inch kips. So 3,000 kips versus 34,000 inch kips. Looks to me like it's a no-brainer. We've got tons of capacity. So bending in concrete is not a problem. So that takes care of that. That's letter O. Compared to MT, resisting must be greater. If not, we've got to make some changes. If MR is greater than MT, we have under-reinforced section. Therefore, a conservative value of J can be used to determine the area of steel. Same as we did before. Remember when we revised AD? It's basically what we're doing here. Now we're going to play with shear. So this is bending. This is bending. Now we're going to play with shear. Did that before. Check shear. For a column footer, we have to check beam shear and punching shear. There's a new term. We did beam shear before. Punching shear, I'll explain in a minute. So we're going to move for beam first and punching second. So I'm going to go to letter S. Beam shear at a distance D from the face of the pedestal. Hopefully you remember, that's exactly what we did last time. So I'm going to come over here. If I can find a pen with ink, and I'm going to take and I'm going to move out here D. Okay, here's my line for bending. Here's my line for shear. So if you look at it, it says, read it one more time. Shear force at a distance D from the face of the pedestal. So there I am. I'm right here. What is D? 17 inches. How do I know it? It's right there. If I take 17, I got 28.5 left over. So this dimension from here to here is 28.5. Hopefully you see the shear force is the pressure pushing up over the area it's acting. So it's acting over an area 8'9" by 28.5 inches. It's pushing up with 3657 PSF. So what do I do now? Look at it. This is shear. Shear. I'm on letter T. It says the force is pressure pushing up times the width times the sectional strip. 28.5 divided by 12. Do the math. Should be done. There's our force. So 3657 times 8.75 times 28.5 divided by 12. I've got 75,997 pounds. So there's the force along that failure plane that's pushing up, trying to disrupt it. So let's go to letter U. Now you can use the formulas if you like. The formula should give you exactly the same number. I'd rather you know, take a look at the picture and use your head instead of the formula. So the next one says I need phi VC. Phi VC. Phi is 0.75. Okay. 2. I think you should hopefully see a real strong link. These are all the same. Okay. Concrete, 3,000. Cross-sectional properties. B, D. B is W. So it's a plane we're going to break. W, D deep. So W is 105, D is 17. And when we get done with this, hopefully this number is bigger than this. This is actual. This is allowable. So that's clear. 0.75 times 2 times the square root of 3,000 times 105 times 17 gives me 146,653. Actual, allowable.